filter tells the digital filter to make the corrections to smoothen out the wavelength. Every console has it. It's called an anti-aliasing filter. It takes all these staircases away and creates a smoother waveform, even though you're in the digital domain. Every manufacturer has it, okay? And it smoothens the staircase caused by digital signal. I have a sound system, the frequency response of 20 hertz to 20 kilohertz. Well, first of all, we don't have a subwoofer that can get to 20 hertz. And nobody in this room can hear 20 kilohertz. So let's see what are the realistics. People of younger age can hear different frequencies. 20 kilohertz now is only used as an engineering frequency. It is not used in sound systems. Why? There isn't a single person here that can hear it. And the reason why we use it in engineering frequency, because only kids at the age of 5 or 6 may be able to hear it. And we use it in a certain amount of voltage so that public address systems use it as a reference or an engineering frequency. We can look at the bandwidth. It's another way for determining the frequency response as a bandwidth. Logically, definition of those two items in frequency response being defined as bandwidth, maybe frequency response can be defined as bandwidth for something. In a data sheet with a high and low number, you look at a data sheet from every manufacturer, there's a high and there's a low number, but what exactly do they mean? There's a lot of brands that you will find that push one data point. Say here's 30 hertz to 26 kilohertz, fantastic. But is that the truth? No. Let's look at your cell phone. Your cell phone has an average frequency response between 500 and 4K. Why? Speech. Speech frequencies. That's why your phone works between 500 hertz and 4 kilohertz. There's no other use for it any other way. Though the human speech can go down, if you're a baritone opera singer, you can go down to as low as maybe 300 hertz if you're a baritone opera singer. Or if you're some opera singer and you're doing a false, if you're doing an alto, you're probably sitting around 3 kilohertz, 2.5 to 3 kilohertz. That's it. The rest of your sound system is nonsense because you actually don't need it. If you're doing a speech sound system, then don't care about anything else you don't need. 500, 400 to 4K, you don't need speakers with big line arrays. Let's look at flat screen TV. 250 to 8 kilohertz. Why? Because you cannot transmit over RF below that frequency anyway. Terrestrial doesn't transmit. But you'll look at a specification sheet and this is what it's going to tell you. It's going to tell you you have a high, oh sorry, you don't have a high, you have a high and you have a low. The problem is this frequency of this speaker is 45 hertz to 19 kilohertz. Without this minus 10 dB, it tells you nothing. But minus 10 dB is exponentially 10 times lower. To be 10 times louder, you need 10 dB. So without this code, it doesn't mean anything. The top code, plus or minus 3 dB, the realistic figure in this thing is actually 170 to 24, actually 19, so it should be 20. Sorry, that's a typing error. Okay, it's actually 170 to 19 kilohertz. Because you're looking at the constant and the minus 3 dB point is where you need to look at. So just don't look at frequency response and say, yeah, but it does this, it does that. No. And again, a very important one to remember. Check your frequency response if it's in half space or full space. What they call 2 pi or 4 pi. This is very important. Why? Because you will get a 4 bounce boundary and it will boost the low frequency of the speaker being in half space. So be careful. Is the rating in full space? That means the speaker's in the air, or is it on the floor? You have two different frequency responses. The speed of sound. Now we know that the speed of sound is constant, but the problem is that's pretty broadband. Sound travels at 343 meters per second. Okay? So that if you hit something over there and I can count it, and I go 1, 2, 3, we can calculate the distance between us. Simple, easy math. But if you have a humid day today, and you have a dry day today, and it's raining, and it's not raining, does sound change its distance based on the medium? Yes, of course it does. So if I say to you, we have a very hot, dry day outside, or a very miserable, rainy day outside, does sound travel further in a dry day, or in a humid, horrible day?
Humid.
What do you think? Any shout outs?
Dry.
Dry? No.
Dry.
Dry day, sound requires medium. How do whales communicate? They wail through echo. Sound. So the more dense your sound system is, the more dense your transmission of medium is, the further your sound will go. Let's take a look at pure water, 1440 meters per second. Let's look at salt water, 1500 meters per second. Now we get into speaker manufacturers, into paper, into aluminium, into titanium, and of course we hopefully are at beryllium, which is about 8,000 or 9,000 meters per second. But the very important thing is propagation. What is propagation of sound? The inverse squared law is a very simple mathematical equation to tell me how efficient a speaker is. If I have a speaker cabinet here and I'm going from point A to point B, okay, I can tell you how much we lost, we know, is the loss of dB by a simple calculation. We have 32 meters to the back row. We know that every time you double the distance from the speaker, you minus 6 dB. Okay? So if we know 32 meters, 2, 4, 8, 16, 32, 35 times 6 is 30 dB of loss over 32 meters. Very simple, easy calculation. So there is an easier formulation to do that. It's called the 20 log system. The distance loss is equal to 20 times the log. Is a very simple calculation. Why? We need this for basic system design, where we decide what speaker we need, how many speakers do we need here to get the result there. We can't just put speakers on a stand and expect it to get a speaker there. We don't know what we need. Because 2 powered speakers, and I will show you that in a second, doesn't quite get you to where you need. Every venue requires this calculation. Sorry, I saw a post on Facebook. This is always a funny one. A rental company on Facebook stated they were getting 102 dB at 105 meters. No. Let's look at the math behind it. The distance in log of 105 meters is 40 dB loss over 105 meters. So the speaker power would have to be 142 dB, okay, at the source. I have one word for you. Biz busted, okay? Be careful what you post on Facebook. There are mathematicians and physicians like myself who go and look at it and go, really dude, really? Really? Okay. If you're going to post something, make sure it's accurate. But do line arrays are the same? I will fast forward a little bit because there are more interesting topics. Is it true I have a line array? A line array is the 3 dB per doubling distance. Oh my goodness. Wow. I'm sorry to burst your bubble, but if a manufacturer is telling you that, It's a simplification of a traditional line array theory. Not true. A traditional line array theory at 3 dB per doubling distance expects the speaker to be infinitely long and infinitely small. Conventional line arrays do not match that. And they don't take into consideration the weather, they don't take into consideration the humidity in the room, they don't take into consideration a lot of other factors. By modeling, I'll give you an example. Just to get a low frequency line array, I would need to get 1,000 15-inch woofers, stack them on each other, and that will become close to a line array up to about 300 hertz. I would have to use the diesel function, but I would need to do that. We would have to space them 20 inches apart, center to center to do it. Not practical. Today's line arrays are different. Line arrays only work in frequencies that extend them hundreds of meters. Somebody's saying I can throw my line array 100 meters. No! There is no magic sound system. There is no magic sound system to say I have a line array, I'm going to throw it 200 meters. No! You can't beat the physics. You're dealing with wavelets, not with brands. The simple way of understanding where a line array is, the simple way is to understand is that if you take a line array, take the array length, this is going to help you find what we call the far field of frequency minimum and frequency maximum. The F max and F minimum is all dependent on the cabinet spacing and the array length. If you have an array length of 5 meters, your maximum far field is going to be 8 times that distance. That's it. And that's the summation point where it's a 6 dB per doubling distance. But it's going to be, again, frequency dependent. I'm doing a session on the last day, line arrays versus point source. This will become a bit more apparent then. Okay, something about sound systems quickly, because I think I don't want to push too far and I don't have enough time. Power testing of speakers. When I tell you it's 500 watts AES, 500 watts IEC, 500 watts peak program, what does it mean? To determine if speaker power's rating is subject to what we call a power test. Okay? It can range from 200 hours to 100 hours, depending on where you are. Now it's using pink noise, which is a filtered white noise. And the reason why we use pink noise is because it's equidistant across all frequencies. However, pink noise came from white noise with filtering added. You have the AES2. Be careful with this specification. AES2 from 1984 and AES2 from 2012. 2 different meanings, 2 different specifications. So if a manufacturer is using an AES2 from 1984 or an AES2 from 2012, AES 1984 will be 6 dB lower. The AES changed the specification to a crest factor 4 or 12 dB crest factor. A lot of manufacturers in Europe did not follow that spec. Why? To get 12 dB crest factor, you need an amplifier that's beyond capable points. There's no amplifiers that can get to 12 dB. So it uses a 2-hour test, okay? All right? It results in a crest factor of 2 and a crest factor of 4. You'll see in the Europeans, IEC. This is the International Electrical Commission. This is a 6 dB crest factor. So then you see a rating. Hold on. IEC rating is very low. AES rating is very high. You need to check to see whether it's 84, 2012, or IEC rated. They have different crest factors because we'll show you inflated dB STL ratings. EIA, I see this more when it comes to life safety regulations. NFPA, National Fire Protection Authority, not in the Philippines, but in other countries, require different ratings of speakers. So We will use some manufacturers for life safety, do reuse the EIA, but important to know is that the duration testing is 8 hours. If you see here, most people that use biamp speakers are using AES, but you must remember they're not measuring the crossover point. That's the big dip. If you look at an AES rating, they're not measuring the center of the crossover point. If you look at the IEC, they are rating at 20K, but it's at -10 or -15 dB. Oh, I have a 4 ohm speaker. What does it mean? Well, they'll tell you 4 ohms. What is 4 ohms, 8 ohms? Does it make a huge difference? Yes. What is ohms? Ohm is a unit of impedance, not resistance. Don't get a multimeter onto a speaker and say, I only have 5.6 ohms. Don't do that. That's resistive load, not impedance measure or reductive loads. When they say 4 ohms, 16 ohm, 8 ohms, what does it mean? It's simple. It's the bottom 20% of the frequency spectrum. Why frequency spectrum? Because impedance is frequency dependent. An 8 ohm speaker will be 8 ohms minimal, 40 to 50 ohms maximum. Why do we need to know this? It helps with amplifier choice. So if we look at a speaker, this is a full range speaker. This is an 8 ohm rated speaker. But at 4 kilohertz, I have 40 ohms. And I have 50 ohms at 100 hertz. If you want this speaker to be very powerful vocally, you've got a problem. Because your amplifier power that you spec'd up has now run out of juice. Because one of the things is, a quick explanation, you burn speakers, rephrase, you do not burn speakers because the amplifiers are too big. You burn speakers because your amplifiers are too small. The dynamic headroom allocation needed in a sound system, you have a speaker rating at 500 watts, you need an amplifier minimum of 2000 watts to handle the transient dynamic peaks of your sound system. Not including, is it 8 ohms, what is the impedance? But this is a great one, average power. You see average power, wrongly referred to as RMS. Who knows the word RMS speaker rating? Does anybody know when you say, I have seen a speaker with RMS rating? Yes? You've all seen a speaker rating that's RMS. Okay? Oops, sorry. Oh, what's that? Ah, sorry. Power is only positive. So the RMS reading has no value. When somebody tells me I have 500 watts RMS, it has no real value. Why? Because the problem you have is that RMS requires signal to go and to come. I'm only dealing with voltage going, so the whole formula doesn't make sense. I do not need, I'm only here, which I need only the mean. I don't need the root of the square because I'm not interested in power coming back. I'm only setting it from the amplifier out. Where you find people use RMS ratings are typically people, manufacturers that are trying to hide something. I can tell you, I know this FPT speaker is not, but I'll use it as an example. I can tell you this speaker is 5,000 watts RMS. Are you going to agree with me or not? You're going to say, Tony, you're talking rubbish. I'm not. Because first of all, there's no testing duration for this. There's no specification for how long I have to test that speaker for RMS ratings. I can say it's 5,000 watts RMS for 500 milliseconds, half a second. And it'll pass the RMS rating. Program power, okay? You see this also sometimes. This is an archaic term from old swept sinusoidal sweeps tests. Nowadays it has no real value meaning. It is simply twice the continuous. Okay? It may be used as a guideline. However, it may be used as a guideline to spec your minimum amplifier power rating. Your minimum amplifier rating. Okay? 300 watt speaker, 600 watt amplifier. Expecting your amplifier to be 95% efficient. It gives you some form of dynamic headroom, but not a lot. Peak power. Please do not waste your time to even look at it. It's a calculated number. It has no zero value to any speaker rating that you see peak power. Why? Because it doesn't tell you how much distortion, what power rating is it put out at, what amplifier was used on it. It doesn't tell you anything. Because remember, 1% of total harmonic distortion is acoustically audible to the human ear. 1%. The sensitivity of a speaker is one part. This is going to tell you the truth. Not always on the data sheet, but this is going to tell you the truth. Okay? We can calculate the speaker rating and the power of a speaker just by knowing the wattage and the RMS wattage, AES wattage, and the 1 watt 1 dB rating. So if a speaker is at the top one, is 300 watts AES at 95 dB, we can calculate where the maximum output is on that speaker. We know that a speaker with 300 watts AES at 95 dB will have a max output of plus 24.7 dB above that. The reason why? You know you have you need 100 dB at the back. Your speaker can do 124 dB, you have 31 dB of loss. Not going to be enough power. When you design sound systems, you work from there, here, not here, there. Everything has to go backwards. We start at the listener and work our way forward. You never design a sound system from the mixing console down. You start from what speaker do you need to do the job and work your way back up. So we know that a speaker at 90 dB, 1 watt, 1000 watts are AES, would have a maximum power of 130 decibels. The spec sheet can tell you what it's like. This is the math calculation. Now remember, when the speaker tells you it's 90 degrees by 50 degrees, what does that tell you? It's the coverage pattern of the horn speaker, or the speaker itself. But remember, what's important to remember is this, is that rating is when the off axis goes to minus 6 dB. So that rating is at the minus 6 dB point. Useful to know, but minus 6 dB is quite a lot of power, 4 times the energy. When you lose 6 dB, you're losing 4 times energy. But don't worry, to the human ear, to gain twice as loud, we require 10 dB. So if somebody comes to you and says, Tony, I want your sound system to be 10 dB louder, twice as loud, I need more power, I want double the power. When it tells you I want double the power, that's 10 dB. Which means take your sound system and times it by 10. Back to frequency response. Sorry, I didn't think. Yeah, sorry, I've covered that already. Half space, full space. Be careful, data sheets will hide this from you. They will put a subwoofer specification that's supposed to be on the floor, and they will on the air, and they will give you a floor mounting specification. Half space or full space, 2 pi or 4 pi. Okay? In this case, we're going to half space, so that means I get a speaker. I take a speaker, I put it on the floor. I immediately gain 6 dB. I take that same speaker, I move it into the air, I lose 6 dB. But there's also something called proximity. Okay, proximity is something that will boost the low frequency as the speaker gets near the floor. So it's important to understand when you're in half space, quarter space, or 1/8 space, be careful, especially sticking subwoofers in the corner. Don't do it. Don't stick a subwoofer in the corner and say it's playing. No, because you've now gained, in this case, we've got 18 dB of gain, but then you're getting into wave interference. It becomes a problem. Okay? Dealing with subs is a little bit more complex. Sorry, 1 second. It's important to understand. Read the specification data notes. Okay? Look at where they're rated. AES rating, IEC rating, 100-hour, 2-hour testing. They don't give you this data, then don't look at them. Read the notes. Go down the bottom of the page. Read the notes. Subs, are they half space or full space rating? Okay? Now, be careful with one you may see with one different manufacturer. I've seen they're doing an AES rating for the low frequency and an IEC rating for the high frequency. Okay? But be aware that you cannot compare other manufacturers to it, but there's not a huge difference between the two. Here's one for you. I found this. I will not tell you the brand or where it is. I'm just going to say this is what I found of a brand that sells in the Philippines. And I want to show you what I mean. Two-way full range speaker, plastic molded. First red alert is, I've got a plastic box. That's my first thing. Okay, I've got a plastic speaker. 1,000 watts power. What? AES, program, peak. What are you hiding? What is that rating? 1,000 watts, 1,000 watts. Yeah, but at what? At what rating do you expect that 1,000 watt to be? 1,000 watts doesn't mean it's 1,000 watts. It could be, it's a 200 or 150 watt speaker continuous. 1,000 watt peak is a 250 watt box. What's the honest truth? They're not showing you anything. If they don't show you something, be very aware. A 15-inch two-way speaker, plastic box, 43 hertz to 20 kilohertz. At what specification? At what minus point? What's the bandwidth? You know? We don't know. My suggestion is, when you don't know, if it looks good, oh, this looks fantastic. If it looks too good to be true, it is not true. The physics doesn't lie. You cannot, we have a saying, you cannot beat the physics. And we cover part of this with System Engineering 101, where we talk about speaker placement. And, you know, okay, I want to put a speaker there, put a speaker there. You can't beat the physics. Oh, it looks good. Yeah, looking good and beating the physics are two different things. The biggest problem I see in production houses is there are people in charge of production that know nothing about sound. And the problem is they're guiding the sound system. Oh, you put a speaker there, you put a speaker there, you put a speaker there, you put a speaker there. No, that's the problem. So, be careful on reading specifications, half space, full space, frequency response. All of this is important information to understand. When you're looking at a speaker, you're understanding, is it really this efficient? Can it really do what it said it can do? If you go to the major brands, okay, if you go to major brands, honestly speaking, if you go to any of the major brands, whether it be RCF, FPT, Martin, JBL, L60, they're all pretty open and honest about their spec. And if not, you can get the data sheets to see yourself wherever. So if you're buying any of the major brands, you're pretty much going to get a spec that it says if it's 250 watts, it's going to give you all the ratings. But it's important also to remember when you look at power of a speaker, you must look at your amplifier power. If your limiting factor in your sound system is your engine is your limiting factor in every sound system. Your engine is your amplifier. Now, when an amplifier manufacturer tells you it's 5,000 watts, it's not 5,000 watts. Because it's a Class H or Class AB amplifier. Class AB amplifiers are only 60% efficient. Class AB may be 90% efficient. Class D may be 95% efficient. It's not going to give you 5,000 watts. Having more headroom in your amplifier to your speaker power rating is critical. It's going to let your amplifier. Make sure you have your limiter settings correct as well. Okay, I think I'm covering, I think I have time, I'm not sure if I have time on the basic system engineering and showing you how to calculate limiter settings. I think I've got that. If not, I'll be on the AES booth for the next 3 days. Come and ask me, feel free to come and ask me questions. Doesn't matter how stupid or how simple, I'm happy to help you. But compare apples to apples, and if it looks too good to be true, it is. Beware, be understandable about where you see a specification and you say, oh, hold on a second, the salespeople are going to drive you, do this, 5,000 watts, 10,000 watts. No. Look at the frequency response, look at the specification, it will tell you the truth. So the next 2 days, I have more than I was supposed to, but I'm doing a session tomorrow on advanced subwoofer array systems, cardioid end fire array systems. I'm also doing system engineering, those who want to start basic system side of it. I am not a front of house guy, please. I'm a systems guy. All right, that's all I've done. My whole life is I've designed sound systems and I am systems. Okay, so I'm not a front of house guy who touches consoles. All right. Well, that's your first alarm bell. There's your second alarm bell. Okay, and the first one is a plastic box doing that frequency response. I know from logic that a plastic speaker cannot go that low. So, if there are any questions, feel free. I'm about, if you stop me, say hello, but if you have any questions about? No questions? Yeah, go on over there. So I'm going to sit down. I get too old. It should be on.
Good morning, sir.
No, sir, just Tony.
Yes, good morning, Tony.
Yeah.
So right now, there's a lot of amplifiers sitting outside. Again, it's considered as lots of ratings. They have some 1,200 watts, 3,100 watts. The question of me is that how can we determine the real RMS or the continuous power rating of one of the amplifiers so that I can match the speaker?
Okay. The first thing is look at the rating of the amplifier. Most manufacturers use something called 25 millisecond burst power rating. Okay, they're all using this burst power rating. It doesn't have any real value, meaning it just shows you an inflated response.
Yeah. Tony, so, is there any device that I can...
no. There are some manufacturers who make amplifier testers, yes, there are.
Actually, right there at the store.
You can buy them online, yeah.
The real RMS, it's really,
it'll tell you, yeah. There are online
showing the real RMS, yes. Even though the manual didn't say that.
Correct, yes.
So
there are testers, yes.
They're all testing, and that's okay,
yes.
right?
Yeah.
Thank you so much, Tony.
Be careful, there are different manufacturers that rate stuff 25 millisecond burst power, RMS power, some using RMS, okay? And it's important, 25 millisecond burst power is not going to help you. A Class AB or a Class H amplifier is not going to be as efficient, one is not going to be as efficient as another. A Class D, Class AB, a Class H will be different to a Class AB. Or a toroid amplifier versus switch mode. They're not as efficient as each other. The old toroid amplifiers used to weigh 35 kilos for an amplifier, and they were only about 60% efficient. That's why you never blew a speaker up with them. Switch mode amplifiers and Class D amplifiers become more efficient, and they're getting more and more powerful.
So Tony, that means that how about those amplifiers coming from China or any other? I think it's more valuable to buy some amplifier that is already a signature line. I think.
Yeah, listen, I may not agree with every manufacturer's way of testing systems. But if you're going to buy a QSC amplifier, you're going to buy an FBT amplifier, if you're going to buy a Lab Ribbon or a Crown or a Martin, I may have my personal preference, but you're buying a specification that's going to work. Just be aware that you need to have an amplifier with enough dynamic headroom to handle the transient response of your material. If you know you're driving subwoofers and you've got a 40 hertz sound wave coming out of the sub, which you're going to have, at 40 hertz, you have 40 ohms of impedance. Your 1000 amplifier is 166 watts. And then when you burn your speaker, you blame the manufacturer.
Well, anyway, transistor plays a lot, right? I think so.
Not a lot. Listen, a speaker
Power
is...
transistor, yeah.
A speaker power is it comes in, power comes in, doesn't come out, it comes in a positive and negative, generates electromotive force, and done. We're good. Okay? The problem you have is that having the dynamic headroom of your amplifier, you know the output voltage of your amplifier. We know, example, 1000 watts at 4 ohm is about 70 volts, 60 plus volts, 68 volts of output. Now, one of the biggest mistakes, one bit of mistakes people make, is that they say, okay, I have an amplifier 1000 watts at 4 ohms, 500 watts at 8 ohms. So if I put one speaker on it 500 watts at 8 ohms, I add one more speaker, I'm getting 1000 watts at 4 ohms. The problem you've done is that you just reduced the power of your amplifier by half. There is no difference in gain by adding speakers to your amplifier line. So getting speaker amplifier and adding one speaker here, then saying, oh, I need more power. By adding another speaker doesn't make it more powerful. It gives you better coverage, but doesn't make it louder. Because now you've got the voltage of that amplifier divided by 2 speakers.
Yeah. But I think the best thing to do is that every speaker, they have their own amplifiers, maybe.
Listen, there are powered systems.
So expensive.
No, there are powered systems. There are good powered systems. I'm not saying there isn't. I love passive tops and powered subs. I like that. That's where
So nice, yeah.
That's my ideally favorite sort of system. But there are powered tops. I mean, great powered systems. There are also great passive systems.
Yeah.
The industry is split 50-50. In the concert sound, it's a bit more passive than powered. But in the MI industry, it's mostly powered and passive.
So it's depend about the use.
We say in England, swings and roundabouts.
Thank you so much, Tony, for that info.
Well, I'm around, so if there's anything else you guys, if you see me around and you have any questions, feel free to ask me. As I said, I'll be sitting with the AES guys for the next few days, so feel free to come and ask, and then we'll crack on from there. Thank you.
Thank you.